In this lecture, we will talk about the concept of sigmoid function, or you can say logistic function, sigmoid function. It is also known as logistic regression. Okay, in this function, we need to know that wherever there is regression does not work amicably, then we will use the concept of sigmoid function. Sigmoid function help us in such a way if we are observing some hypothesis function equivalent to 0, then our sigmoid function can be expressed in form of, or you can say zero 0.5. This is the sigmoid function. Basically, this represents the hypothesis for nonlinear case. If we are talking about the graphical presentation, then we should know that this is the center point where it is 0, or you can say that is our hypothesis equivalent to 0, and this 0.5, this 0.5 basically is somehow, this is 1, this is 0, okay. Our graph is somehow like this, and this is a point where it is 0.5. It's in the medium, or you can say it's in the midpoint somewhere. If we are talking about the classification thing, then we can say that if there are some two different classes at this point, or you can say 0.5 is a decision boundary which differentiate between the positive as well as the negative cases. So this is the classification at this point. So whenever we are talking about the sigmoid function, we need to determine at first place the value of weight parameter theta. Then we need to consider the x-axis in terms of you can say some kind of an input, and these inputs kind of a binary values, can be 1, can be 0. Let me explain in terms of linear function, as we can categorize that output will vary from the negative infinite to the positive infinite. However, derivative is a constant. Derivative is a constant, or you can say then we will get a straight line. If derivative is not a constant, then we will get such kind of a line. But it's once derivative is a constant, then we will get a straight line and the function is a linear. However, sometimes we are dealing in such a way that the simple is not a linear, or we need to differentiate the non-linear classification. So non-linear classification case, we need to, for example, here if we are talking about some kind of a cancer case, one is if the tumor cell is benign, of nature of benign nature, then of course it's not very much dangerous. Our blue circles represent benign nature. It can be this side or it can be on the opposite axis somewhere. So like here, okay, this side or this side. So this is the non-linear case because somewhere, okay, the dispersed, so benign tumor cell, benign nature is in the dispersed way, and if we see the cross we can consider these are the malignant. These are in such a way that it is very difficult to separate if we are with the help of a line. If we are separating these with the help of line, so we are getting some kind of a mixture, and this mixture is not acceptable in terms of a machine learning case or deep learning case. So what we need to do, we need to configure such kind of a thing which can help out to localize this boundary in a non-linear classification. So this is the way. So black line is around the red cross is representing that we need to classify these malignant tumor cells in a non-linear way. So this is a problem, and this problem can be sorted out with the help of neural network. So this neural network determined with the help of a sigmoid function, and this ranges between the 0 to the 1. Okay, so 0 here at this point to the 1 at this point. Okay, this will be classified between the two possible values, 0 at the 1, maximum at the 1. So the range between 0 and 1 will be classified. It can be 0. For example, somehow at this point 0.85. If the size of a tumor cell, then it can be classified as a malignant. It will be categorized according to the clinical expert, neurosurgeon, who will decide that if the size of a tumor is this one, then it should be a some kind of a malignant. So it is adjustable, kind of a, we are getting this sigmoid gradually going up, then again it is getting some kind of a straight along the one value. So, and formula for this if we are considering this value hypothesis at the 0, then we will get at the 0.5, that it is the 0.5, that is at the center somewhere. So we need to determine the sigmoid functions. Again, the uses of this sigmoid functions will help out to localize the non-linear classification of a system. Similarly, like sigmoid function, there are many other functions like 10 hypotenuse functions. It is also work like this, but here it's not, it varies. Range is somehow, you can say in previous case we can notice the range is between 0 to 1, but in 10 hypotenuse range is -1 to 1. Similarly, we can also note the expression formula of this 10 hypotenuse is this output. Similarly, we will get another function, that is the ReLU, okay, the rectified linear unit. This is also having some range somehow between 0 to infinite. It's used in the computational complex problems, and ReLU also somewhere at one end you can say, because here not you cannot say it's started from somewhere negative infinite value, it should be greater than the 0. So in this case gradient behind the 0 value is all constant. So this is in the constant fashion. Basically, once we are talking about the constant, then usually system is in sleeping mode. Once the system is awakening, then we will getting some kind of a gradual improvement in terms of a line. So this is the rectified linear unit system. We will study it at the later stage. However, we will try to know what is the non-linear activation function. This is very much important, and it is accomplished with the help of sigmoid function. As we can notice, if the data is dispersed with the help of linear regression system, we cannot configure the data that the difference is this point difference, this point difference, so somewhere the difference, so this is kind of error things. We will not estimate our required output in a better way. Therefore, we need to consider a nonlinear system. And nonlinear system, as we already observed the sigmoid function, it has some kind of a flexibility. So you can behave along the points in a little bit fashion along the curve. So we can determine with the help of activation functions how activation functions work with the sigmoid function or other 10 hypertenues or the rectified linear unit. Let's see the system. But before proceeding to this, I would like to clear about the loss function. Loss function basically is used to quantify the deviation, that how much it is different from the benchmark thing. If we are getting some kind of output, observed output on the basis of experiment, on the basis of our calculation, we need to know how much it is deviating from the benchmark, standard things. Similarly, in all this, we can notice the scaled error. Scaled error, as I already explained, least square error is also the one of the example. Other is the our loss in the binary classifications. Entropy, somewhere we are using a simple probability or Bernoulli distribution, true false kind of a coin toss, we can get the binary classification. Similarly, for multi-class classification, we are also again using the entropy things, and where for example, we are partitioning or classifying 3 or more things, then one by one we will classify, then we will proceed further with the help of multi-class cross entropy. So this all is used to determine the loss functions, and these loss functions can be categorized in the following 3 criteria. So purpose of all these 3 criteria is to optimize the error, or you can say technically we want to reduce the error so that small negligible error we try to optimize it in such a way that the loss function should be minimized. An important thing that if the loss function is huge, then we will at the risk. So too much risk is dangerous for any task. Therefore, to minimize the loss function, so error should be negligible, so we can pass the test, or our robot, our deep learning, our automatic system work amicably without any big trouble. So how we can do this? We need to tie the loss function and the model parameter by updating the network, and this updating is of course we need to apply, we need to perform certain iterations from turn to turn, and of course this is done with the help of gradient descent, and gradient descent I already explained that it is the iterative algorithm that starts off at some random point on the loss function and travels down to its slope in steep steps until it reaches the lowest point. Point, or you can say amicably stepping down from the top of the mountain to the bottom. If we will consider a big jump, then convergence will not be attained. Convexity is a big problem in this situation. So amicable step, or the step function will be a small amount of step function will be used, so that but the step function should not be such a small extent that it is taking ages to complete it. We need to consider the step function some kind of a moderate range, so we can achieve the some lowest point, or you can say that the minimum point or our target point. in this case, our algorithms calculate the small change. Of course, our moderate value of the step function will give us a small change in each and individual weight will also be applied, and our weight value will be considered with the help of some biased value. Okay, this is following some kind of equation of line. So where we can say that slope and with some biased value, or in the hypothesis cases, we can also write like theta naught, okay, theta 1 x1, where this is of course the same thing, biased value of the benchmark. Okay, here is the x naught, but usually we know x naught is representing some kind of the object, or it's equivalent to 1. Therefore, usually we do not mention x naught. So in cases of house, we are representing that the quality of house or the quantity of house. This one is the quantity of house, 1 unit house, and of course if we are talking about the price of the house, it is telling with the help of its weight parameter how much it is of significance, how much its quality. So we need to iterate it until we need to observe different examples of the houses to know better the value of the houses. So in deep learning, basically it is kind of a learning, okay, so with the help of computer to synthesize the art, or we are using it for many purposes, render the medical diagnosis, or self-driving automatic cars, all the robotic systems, small tiny objects, even we are playing with the mobile phones, Android applications, all depending upon the this deep learning systems. So if we notice the concept of deep learning is the core thing of all the artificial intelligence and machine learning. If someone familiar with the deep learning, then okay, of course he will definitely understand the artificial intelligence and machine learning. So deep learning is using the somehow you can say with the help of deep learning we can extract the patterns by using the data in terms of neural networks. Once we are talking about the neural networks, then we need to notice how we can understand the concept of